Against the backdrop of high-profile world events, the awarding of the Nobel Prize in Physics in 2022 has remained in the shadows, and for nothing. After all, the prize was given for evidence that our universe is not real. Yes, I did not misspell. Reality turned out to be more complicated than it seems, and Elon Musk's theory that we are living in a simulation has taken on new colors. In the next couple of minutes, we will try to explain the revolution in understanding the universe and the cosmos in simple words. Let's start by understanding what is considered real at all in terms of physics. Paradoxically. But the question has been a problem for the scientific community for centuries. Intuitively, we can separate our dream with naked Scarlett Johansson riding an otter around Hogwarts from reality, but science doesn't like intuitiveness, it likes clear definitions and dry formulations. You've probably often heard the definition of local realism, localized reality, and other variations where the word reality is combined with localness. This is it, this very definition of reality that existed before 2022. Real in physics, since Newton's time, is that which has definite and finite characteristics, regardless of the observer. Scarlett Johansson exists only in your dreams, appearing and disappearing. But the New Year's tangerines in the store will be orange before you even go shopping. There are also quite popular philosophical questions, such as the one about a tree falling in a deserted forest. Will there be a sound of falling if there is no one to hear it? From the point of view of physics, the question has long been irrelevant. Of course there will be a sound. A tree has physical characteristics, and therefore it will interact with its surroundings. It will not always be predictable, but always. According to the laws of physics, humans in this equation can only act as eardrums to catch sound. In other words, knowing the characteristics of an object, its behavior can always be predicted. This is actually the second postulate of reality voiced by Newton. The scientist claimed that if you know the positions, speeds, and characteristics of objects, and are aware of all the forces that act on them, you can easily predict what will happen to them in the future, and at the same time in the past. That looks pretty ironclad, doesn't it? Newton was a big supporter of Newton. And the whole of astronomy. I mean, come on. Planets, asteroids, and other galaxies have been discovered on this principle. Now we know the characteristics of the Sun, its speed, and all the forces acting on it, and we can easily predict that the next solar eclipse will happen in 2024. By the same logic, it is open early, and the fate of the objects of the solar system is scheduled for thousands of years in advance. The word local is added to the definition of reality to clarify the process of interaction of objects. Only nearby objects can influence other objects, and the speed of propagation of this influence has a familiar limit in the form of the speed of light. It is important to realize that local and nearby objects do not necessarily mean nearby objects. The star Aldebaran, 65 light-years away for an observer on Earth, is considered local. Light from it falling on the retina of the human eye and interacting with it is local, because on its way it spreads through the nearby space and does not violate any laws by spreading. Pardon the pun about the speed of light, but no higher. In other words, locality is a caveat to exclude esotericism, the supernatural, and other conventions from the definition of reality. Anyway, the definition of reality is strong and logical, and then quantum mechanics came on the scene. You are all aware of the experiment with electrons in two slits. If the electrons are not observed, they behave like a wave. If you add an observer, the electrons get confused and start behaving like particles. The description is, of course, very superficial. And we apologize in advance to all physicists. We do not need to go into the experiment itself now, but the main thing to realize is that quantum mechanics in general of its birth began to break the classical definition of reality. A tangerine on a store shelf is always orange, even if nobody looks at it. An electron, in theory, should be a physically defined object and behave the same way whether someone is looking at it or not. Our reality has cracked, but at the beginning of the 20th century few people paid serious attention to this. Einstein, for example, did not call the experiment with two slits and it's like a fake. The scientist, until his death, believed that we banal do not have the necessary precision instruments and the laws by which these particles behave. In his understanding, the definition of reality did not fail, just the level of physics and the behavior of the smallest particles did not allow to understand. It was settled, and the 20th century passed under the aegis of rivalry between the two systems. On the one hand, there were quantum physicists, who every year found more and more mystical and mysterious properties of elementary particles, declaring that our world works quite differently. And on the other hand, there were classical physicists, who condescendingly declared that someday we will connect everything, just now we are not strong enough. The Einstein-Podolsky-Rosen paradox became the battlefield of the two systems. When studying the behavior of elementary particles in quantum physics, quantum physicists realized with horror that they can be in two places at the same time, have two characteristics at the same time and influence each other. The electron, which we remember from physics lessons at school as a kind of satellite orbiting the atom, turned out to be absolutely not so in reality. The electron is in every point of the orbit at the same time, just with different probabilities. Schrödinger's code and other quirks of quantum systems are probably, at least superficially, but familiar to you. However, the Einstein-Podolsky-Rosen paradox is out of the rule. If only because it is scientifically proved that it is impossible to explain it from the point of view of ordinary physics. To understand the paradox, imagine that you and your friend Vasily have traveled to different ends of the solar system. Two coins are thrown to you from the ground, they start spinning, and the moment Vasily sees whether his coin is eagle or tails, he will clearly know which side of the coin fell. It sounds silly to you, because it is pure chance, and Vasily should not know what will happen to your coin, based on his data. However, in the quantum world everything is exactly like that. Moreover, in the experiment Vasily not only learns about the state of your coin, he directly affects it. Einstein famously said, "God does not play dice." However, modern research shows that he does. Quantum teleportation was described in 1993 and, in a nutshell, it involves creating a pair of coins similar to our experiment. They are quantum entangled, and it turns out that at a great distance we get a coin whose state is predictable depending on the first coin, and it doesn't matter how far away it is. Sounds like magic. But in June 2017, Chinese scientists, using an emotion satellite, teleported to an investment 1,200 kilometers away. This, of course, is not exactly teleportation. The procedure is more like cloning a particle state and reproducing it elsewhere. But however it works, and there are dozens of successful experiments, which brings us back to the question of the reality of our world. It is logical to assume that by changing their state in the process of quantum teleportation, particles somehow exchange information. The only problem is that in this case it happens faster than the speed of light, which is impossible in the current definition of local reality. At least the expression of locality falls under a blow because of violation of speed mode. Things got even worse when the postulate that elementary particles have a predetermined state came into question. This, in fact, is the subject of the work of John Clauser, Alan Aspect, and Anton Zeilinger, winners of the 2022 Nobel Prize. They studied photons and other elementary particles, trying to find an answer to Einstein's question, do we really lack the equipment to measure the characteristics of tiny particles, or do they not exist after all, and they appear only at the moment of measurement? The team of scientists proved that the characteristics of elementary particles do not have, they appear only at the moment of measurement, and therefore, the reality of our universe cannot be called. To understand this clearly, let us return to the experiment with two slits. Yes, the behavior of particles and the pattern they form depend on the observer, but we cannot predict where a particular particle will fall. Einstein thought we didn't have enough knowledge to predict its behavior, but Nobel laureates have proven otherwise. Some aspects of how the quantum world works are indeed unpredictable and random. Tiny particles have no physical parameters until we measure them, and there are no laws, formulas, or definitions that we lack to relate quantum physics to ordinary physics. It must be studied as I have it, for our reality, friends, this is a quiet horror. It turns out that the universe behaves differently at different scales, and it is impossible to pack it into human logic. What is predictable in the visible world is unpredictable in the quantum world. However, after all objects in the visible world are still made up of particles in the quantum world, which are completely unpredictable and only show their characteristics if you look at them. And the funny thing is that somehow the connection between the two completely different worlds works. That's the funny thing. Elon Musk and other prominent proponents of the theory, who claim that our world is a simulation, are the most happy about the Nobel Prize in physics. Simulation in the quantum world is really up to more similar to the principle of operation of modern neural networks with machine learning. They don't have a picture of a raccoon in a RoboCop costume on their hard disk. However, if you ask, the neural network will generate queries and dump the results. So too, tiny particles have no characteristics until requested. Aren't we in someone's computer that saves resources and doesn't bother drawing small textures until we look at them? Unfortunately, it's hard to deny that. However, underestimate the epical nature of physical discoveries as well. Electricity also seemed like magic to people at one time, and perhaps in the future there will still be a simple and straightforward answer. And whether you believe that we live in a simulation, leave your opinion in the comments. Thank you for watching, dear friends. Your kind words and support motivate me to make more and more interesting videos. Don't forget to subscribe to our channel, because we have many more interesting and exciting things to share with you. See you on our space journey.